and 12. Okay, now we go to the final part. Mohr circle for plane stress. In this case, in this topic, actually, you have this I said about the alternative method. If you don't use the equation that you have seen before, you use this Mohr circle. Okay, you will have the same results. But I prefer you guys to, I suggest you guys to learn Mohr circle more, because this is more comprehensive. Okay, when you have drawn this kind of circle, this is the circle. This is the circle. If you have drawn this circle, so actually you can control it. Any rotation is fine by now. Okay, you can rotate at any point that you want, at any angle that you want. Okay, so this is from before. Okay, you have defined your sigma x prime and tau x prime like this, right? And then please recall your sign convention. Okay. Okay, no. Now we're going to represent this state of stress into this Mohr circle, right? So before you do that, you have to know the sign convention of sigma. It is positive going to the right, while for tau, it is positive downwards. So basically, before you draw the circle, of course, because this is the graph, right? So you need to have x and y axis. So in this case, your x-axis is sigma, horizontal axis is sigma or abscissa. It goes positive to the right, like the normal x-axis. Okay. While your y-axis or your ordinate axis is tau, okay, but it goes downwards as positive. You see this tau goes downwards as positive. Don't make mistake here. If you do the other way around, then we're wrong. Everything's wrong, right? And okay, and you need to know, of course, okay, now you have established sigma and tau axis, right? So in order for you to draw the circle, you need to have this center of the circle C, right? And the reference point P. Sometimes this book they use P and sometimes they use A. So I mean, as long as you understand this that's fine. Okay. So this C, this center of the circle C, the coordinate is sigma average tau equals to 0. Right. Now remember, put this into the graph now. This is always sigma and tau, isn't it? The coordinate. Sigma and tau, sigma and tau. So the sigma of this point C, the center, is sigma average, okay, which is sigma x plus sigma y over 2, while the tau is 0. All right, this is the center. And then your reference point P here, right, is sigma x, okay, for sigma, while for tau, it is tau x, y. All right, so these two are the starting points for your circle. So you need to know the circle, the center first of the circle, which is sigma average 0. Okay, sigma is sigma average, tau is 0. While for point P, the reference point, or point A, the reference point is, the coordinate is sigma equal to sigma x, tau equals to tau x, y. Right? And then you see, you find the radius from this. Right? I hope you, I hope you can check here out on how do we do that. And then you can draw the circle. Right? Of course, we're going to go into details of that. Okay. So this is what I said. The reference point of A is the coordinate of sigma x, tau x, y. Right? The reference point. The center is sigma average. For sigma, tau is 0. All right. And once you have, of course, you have the radius as this, right? Once you have drawn this circle, you remember your principal stress, sigma 1 and sigma 2, principal stresses, maximum principal stress sigma 1 and minimum sigma 2. From this Mohr circle, this is your sigma 1, this is your sigma 2. Right? That's why he said that sigma 1 is the max, sigma 2 is the minimum. Right? Can you see that along the circle, around the circle, at any point around the circle, sigma changes, right? and the maximum is sigma 2. It increases, reaching sigma 1 as the maximum. Okay, so these two are the maximum. Sorry, the principal stresses, sigma 1 and sigma 2. Right? While on the other hand, you have another one. I mean, important point. If you draw vertical line, you see that this is the maximum tau, and this is maximum tau, so minimum tau in this case, yeah. But of course, they have the same values, right? So this is what? Your tau max in plane, the maximum in plane shear stress, right? So that's why I said this Mohr circle is nothing new. It's just the another alternative method to find this principal stresses and the maximum implement shear stress and any stress for any rotation. All right. Okay. So how to draw this? First, like I said, you establish the coordinate system of xy from here. Okay, this is the original state of stress, right? Xy, x. So you have sigma x, y to xy. So x goes this way, y goes up, right? And then you define sigma x, sigma y to xy, of course, from here. I mean, this is the same like what we have done before. And now we go to the Mohr circle, which we have to establish sigma and tau, right? Remember, positive sigma goes to the right, same as x. But positive tau, it goes down, not goes up. It goes down for positive tau, right? And then you plot the center, which is, the coordinate is sigma equals to sigma average, tau equals to 0, okay? Sigma equals sigma average, tau equals to 0. So this is the center, right? Sigma average is what? Sigma x plus sigma y over 2, okay? And then reference point, A or P, whatever. Sometimes they use this as a P. So this reference point. What is the coordinate? Sigma equals to sigma x, tau equals to tau xy. All right. So you take sigma equals to sigma x, tau equals to tau xy. All right. And then you know your C, you know your P. You can have your R, okay, the radius, okay, the distance between them. And then from this R, you can draw the circle. You can find this sigma 1, sigma 2, and of course your tau max, which is in the case your tau max in plane, which is maximum in plane shear stress is radius itself, right? From C to this point, to the maximum point is radius, isn't it? This is radius. So just radius. Simply, as simple as that. Okay. So let's look at this example. So you have this shaft, solid shaft, fixed at point, not point A, at this point, at this location, and then you apply the compressive force P, you apply the bending moment M, you apply torsion moment T, right? And then you take one point A, okay, you take it as an element, plane element, and then you see that, okay, now I have this compression of 12 megapascal and whatever stress is 6 megapascal. So first thing first, what are these? You have to establish XY. Okay. Of course, this coming from this. Okay, to get this, chapter 8. That's what I said before you go to chapter 9. This is chapter 8, right? Now chapter 9, you want to find this. What is the maximum stresses that will occur? Okay. Okay, now okay, so you establish XY. So basically you have your sigma x, you have your sigma y, and you have your sigma x, you have sigma y, and you have your tau, so tau x, y. What are they? Sigma x minus 12, isn't it? Minus 12, compression 12. Sigma y is 0 because there is no shear, normal stress in y direction, isn't it? While your tau xy is minus 6. Not 6, minus 6, because you again look at the right hand surface, you have it, the shear stress going down, so it is minus 6 megapascal, right? And then to construct the circle, you know your sigma x, you know sigma y, you know your tau xy. You can find the average, which is the center, right? The sigma location for the center. So you have this average, and then you know the center, you know the P is sigma x, which is minus 12, and tau xo, which is minus 6. So you plot it as here. Actually not here. This is for the original one. I mean here, this one. Okay, that's why it's strange, right? And then okay, don't look at this. I mean this is the original one, so don't. It's not like don't look at this, but this is the original one. So I mean we don't show plus and minus here. So okay, now you find the radius. Okay, how to find the radius? So you go back to here. So this is C, which is sigma average minus 6, isn't it? Minus 6. Okay, from sigma and tau exists, you go to the back, minus 6, and then A is, minus 12 minus 6. So minus 12, right? Minus 12 minus 6. Okay, tau going down is positive, so going up 6. Okay, minus 6 over here. So you can have this radius. How do you do that? Have the radius, you have to find this one. You have to find this one. Of course, this one is 6, right? What about this one? This one is 12 minus 6, isn't it? 12 minus 6 is 6. So in this case, this radius is, you see, 6 squared plus 6 squared, it is 8.49 megapascal, right? And then to find the shear stress, now, principal stress, now you draw the Mohr circle. You draw the circle from C to A, you draw the circle, okay? And then you got these 2 points, which are point B and point D, which the circle which intersects sigma exists, right? So this one is maximum principal stress, sigma 1, while this one is minimum principal stress, which is sigma 2. Right? So for sigma 1, what is this? It is the radius, right? CB is radius minus 6, which is sigma 1. Right? While for sigma 2, it is what? It is minus 6 minus radius, isn't it? The coordinate of that. From 0, sigma equals 0, the tau exists. You go minus 6 to point C, and then you go further radius, okay, which is 8.49 to reach point D. So it is minus 6 minus 8.49. So you got this sigma 1 and sigma 2. So you have your principal stresses are 2.49 tensile and 14.5 compression. Right? And how about the angle? Okay. The angle is, you see, from point A, remember this point is the reference point. How do you reach point from A to D or A to B? In this case, okay, let's do this, A to D. From A to D, how do you do that? You need to rotate it, see, from A to D anti-clockwise, isn't it? So this is the angle 2 theta P2, right? Remember, theta P is the angle that you rotate to reach the principal stress, right? Theta P2 means that the to reach the principal stress of theta 2. Sigma 2, right? This one, point D. Of course, you rotate to B, then it becomes 2 theta P, Q theta P1, right? But this one, you rotate from A to D, so point D is sigma 2, so it is 2 theta P2, right? Why 2? Because remember, in Mohr circle, it is twice the angle of the original state of stress, right? So you can find this angle, right? The angle is, so basically if you do tangent 2 theta P2, you will have 6 over 12 minus 6, right? And then you will have your theta P2 as 32.5. What does it mean by that? It simply means, right? It simply means from this x-axis, see this x-axis, you rotate it 22.5 degree anti-clockwise, you will reach this sigma 2, which is on this surface, or on this x prime axis, you have this 14.5 megapascal compression, which is sigma 2, right? On the other hand, okay, when you rotate from A, which is x, okay, you rotate it to this, right? And then you reach sigma 1, right? Which is this 2.49 megapascal, right? So it is 90 plus 2.5 degree angle, right? Oh, sorry, this one. Okay, now go to the next example. Okay, before this one we find the principal stress. Yes, principal stress. Now we'll find the maximum in plane shear stress. So here again, I want to go quickly. So you have sigma x of minus 20, sigma y plus 90, tau xy plus 60. Okay, and then define this, right? So the question asks you to find the maximum in plane shear stress. At this point, you use your Mohr circle. So you see the center, okay? The center is the average, sigma x plus sigma y over 2. Okay, you got this average of 35, so it is to the right, right? Sigma x, sigma exists to the right, tau exists going down. So the coordinate of C is 35, 0, right? 35, 0, right? And then the reference is sigma x, tau xy, which is this reference A. Okay, it is minus 20 for sigma, plus 90 for this is minus 20, okay, for sigma, and plus 60 for tau. And then you have the C and A. You can find the radius, which is basically just look it. I mean, okay, this is 35, right? From C to the tau axis, right? And then from tau axis to A is 20, isn't it? So 35 plus 20 is 55. This one. And then, of course, this one is 60, right? Because this is the same as tau xy. So 60. 60 squared plus 55 squared. So you have your radius, which is 81.4. So you have this radius. You draw the circle. Of course, this is your, again, sigma 1. This is your sigma 2, right? But here, if we are interested with your principal stresses, you are interested with this, which is the tau max in plane, right? So you rotate this from A, the reference point A, to E, okay? Point E. Point E, which is the location of the maximum in plane shear stress. That's what you want to find. And then you need to find the angle, which is the angle is 2 theta S1, right? To find this angle, okay, basically tau max here, like I said, it is actually equals to the radius itself, right? So the radius is 81.4, so the tau max in plane is 81.4, right? The average is, and then the normal stress that is applied to the four surfaces are the average, which is 35, right? And you can see it from here actually. You see that this at point C, what is the coordinate of this point C? Point E, right? Point E is sigma average, isn't it? The sigma is sigma average. The tau is tau max or R, right? So that's why you have sigma average and you have the tau max in plane, which is R, the radius, right? And how about the angle? How much it needs to be rotated? So this is 2 theta S1. Again, 2 because in Mohr circle it is twice of the real angle. Okay? So you need to find what is this length, right? And what is this length? Of course, this line, the horizontal line, you already got that, 35 and 20. And of course, this one you have found as well. This is 60, right? So this is 60. While this is, how much is it? 55, right? So you do tangent 2 theta S1 equal to 55 or 60, okay, this one. And then you solve that one, you'll have your theta S1 equals to 21.3 degree. Okay, what does it mean by that? It means from reference point A to E, you rotate it 21 degree, and then you will reach your principal, maximum in plane shear stress. So again, you start with your X, right? The X from before, X exists from before. You rotate it 21.3, which is the the maximum angle, right? Maximum stress angle, maximum shear stress angle. okay, 21 degree anti-clockwise. Okay, why? Because you rotate that. Okay, from the Mohr you see that you have to rotate anti-clockwise to 0.3, and then at this point you reach what? You reach point E, which is sigma average and tau max. So you have sigma average, okay, 35 megapascal positive, and you have your tau max, which is 81.4 megapascal. Positive, right? At point E, this is positive tau max, right? Positive tau max. So that's why on this surface that you rotated, you have 81.4 megapascal going up. All right, and then the rest are complementary. Okay, this and this and that. Of course, that let's say sigma average of 55 megapascal will be applied to uh, all four faces, and the rest of the shear stresses are the complementary shear stress. Of course, if you want to rotate again and also you can do that. Okay, to find this, for instance, the one here, you can rotate and then you see. Okay, what you have to do is you rotate to point F and then you see what happened. Right? If you rotate to point F, okay, then you will get this one. Right? Okay. Now we have done with the maximum, which is the principal stresses, right? The maximum of normal stress and maximum implicit stress, okay, maximum for the shear stress. So now we want to see that actually it doesn't have, I mean, this Mohr circle or the one that you have done before, the general equation for the stress transformation, you can do this for any rotation, right? For instance, in this example, the question asks you to find what happened to this state of stress if you rotate this 30-degree anti-clockwise, right? So you have to rotate this 30-degree anti-clockwise, right? From this to this, right? And this theta equals to positive 30 degree, right? Of course, we have gone very far now. Sigma x equals to minus this, right? Sigma y equals to plus this, while tau xy equals to minus this, isn't it? Okay, this is what you got. You can find the average to find the center, right? And then from the center C and then the reference point A, the formula is what? Sigma x tau xy, isn't it? Okay, you can find the radius. Okay, this is your radius, to find the radius. And then what you have to do is from this Mohr circle, okay, from CA, of course you draw the circle first, okay, with the radius of 11.66. And then what happens is that you rotate how much? The question asks you to find what happens if you rotate this 30-degree anti-clockwise, right? So you have to rotate anti-clockwise 60 degree. This one, 60 degree. Why 60 degree? Again, Mohr circle is always twice of the angle in the Mohr circle is twice of the angle that you rotate in the state of stress. Okay, the plane. Right? So what is the idea here? If you rotate, you see, if you rotate it 60 degree in this Mohr circle, which is equivalent to the degree of the real plane element, you see that from A you rotate, you reach point P. So this point P, sigma x prime here and tau x prime y prime will be the state of stress of that element when you rotate it 30 degree. You understand that? Right? So you have to rotate from A to P 60 degree in the Mohr circle to get this point P, which is the coordinate is sigma x prime, tau x prime y prime, which are the state of stress. Okay, so of course when you want to do this, you need to find the angle here, right? Because it's 60, so you have to find this angle first, right? This phi angle. Okay, so how to do that? You have to do tangent theta equals to 6. Oh, yes, is fine as well. So you can do tangent theta, which is 6 over 8 plus 2, which is 10, right? This is 5, right? And then, of course, this angle is 60 minus 5, right? So you get 29.4, which is this angle. Why do you need to have this angle? Because can you see this? This is C, right? And this is P. So this is the angle, right? You know that this is 11.66, the radius. This is C, this is P. This is the angle that you need to find, which was 29. Okay, this is 29-degree angle. If you know this, you can find what is this, right? And what is this? If you know this, then you can find the coordinate of P, and that is the state of stress of sigma x prime, x prime, y prime, right? So that's what you do. So for sigma x prime, it is 2 minus a2, 2, and then going beyond that, okay, to have this, sorry, this is actually 11.66, right? And then what is this distance? 11.66. You have the radius of, okay, the hypotenuse of 11.66, right? So if you do cosine, okay, you do cosine 29 equals to that 1 over 11, right? So that's what you do. And for tau x prime y prime, okay, what you do is you take this distance, which is sine 11.66 sine 29, right? And this one. So you see, this is sigma x prime, and this is tau x prime y prime, right? And then what you do, you have to do next is you rotate that 30 degree. See, from x to x prime 30 degree, you will have your compressive stress of 820, 8.2 megapascal, isn't it? And you have tau x prime y prime, which is positive 5.66. That's why it goes up, kind of up, right? Okay. While on the other hand, for the other surface, right, what you have to do is you have to go to the other side, which is point Q. Okay. So you need to rotate from A to Q. So all the way from A to Q is, this is 60, so this is 125. Sorry, 120, isn't it? Because the line, the angle of the line is 180. So this is 120. So you need to rotate from A to Q. You need to rotate 120, and it is equivalent to how much? 120 divided by 2 is 60 degree clockwise, isn't it? You rotate clockwise from A to Q. Right? So at that point, you can find your sigma x prime and tau x prime y prime, okay, to be this and this. So you see on this, dE, okay, this is basically coordinate, okay, 12.22 and minus 5.66, okay, this one of coordinate of this, which is 12 and minus 6, isn't it? 12 minus 6. Something like that, 12 and minus 6. Minus 5.6. Right? So you see what happened on the surface. Okay, you rotate it from x, the reference, right? The reference is A, point A. You rotate it 60 degree clockwise, you will reach your tensile tension stress of 12.2 megapascal, and you will have your shear stress of 5.66 megapascal, and it goes down 5.66. Why? Because it is minus. Okay, of course the rest will be complementary, right? Okay, we will solve this tutorial inshallah 11 and 54, and that's end the end for chapter 9. Thank you.